What is up, guys? I hope you are good. So just before I continue to do whatever that I'm going to be doing now, I just thought let me make the second video on components. So let's see what we're gonna deal with today. We're gonna deal with let's go with MOSFETs and diodes. Okay, let's go with those two. I'm hoping that I'll be able to make a single video out of this. So number one, let's go with diode. This is the simplest to explain. Doesn't really have a lot of information that you need to know. So as much as I'll explain according to me, you can always watch other videos over YouTube or read books really, and you can be able to get the information that you need. But anyways, I will explain these components according to my understanding in the way that they work for me. Yeah, so one thing that you have to keep in mind is that I don't have any educational background for this, and the highest level of education that I know about this is high school. But anyways, let's explain them. So diode, typically it is represented by the letter D, and it looks something like this on a circuit board. Oh wow, what am I doing? And there we go, that's a diode. So basically all it does is it allows power to go from one direction to the other. When you try to feed power in the reverse direction, it just doesn't work. It never works. So how do they apply this? So remember I did mention that they do put these as a reverse protection on certain motherboards, in particular ASA. Let me check it up for the motherboard here. I'm gonna pause and find a motherboard that's got that application. Okay, so I'm back. So this is basically the diode that has been put in this circuit in reverse. If you take a look over here, grab a tweezer. You've got your charging port which comes through here. You've got your first MOSFET, your second MOSFET, and then your current sense resistor. From here, this is now a main power rail. But we've got this diode over here and these capacitors and that resistor. So this diode over here, it's been put in reverse, which means it has been put in such a way that if you plug a charger, power can only go from this side to this side. But if you put power from this side coming this way, it doesn't work. Where is my multimeter? Okay, it's there. So that's why most people will say put your multimeter in diode mode or beep mode. So there I am, I'm in beep mode. If I put across like this, I don't get a beep. And if I put across like this, I get a response. So it's not a beep, it's just a response. There. If you put it this way, you get a measurement. And if you put it this way, you don't get nothing at all, no response. So what it essentially means is this circuit. Let me draw this particular circuit on a diagram. So you do have your charging port here, which has got your negative and your positive. So your positive is coming in, your positive 19 volts into the first MOSFET, second MOSFET. Output, you've got your resistor here, and you still get your plus 19 volts. So if there's a 19 volts coming in into the first MOSFET, second MOSFET resistor, then it's going out. So this will mark it as our Q1, and we'll mark this, let me make sure that I'm focused there. We'll mark this as our Q2, and we'll mark this as our R1. So our diode now, So as you can see here, we've got your negative going also the same. Our diode is connected over here like this. So it is connected like this, which simply means that if you've got your 19 volts coming in this way, it can't pass through because it's been put in such a way that it goes only in that direction. So power will just continue straight. The laptop works fine. But if you put your charger in reverse and you've got your positive this side instead of that side, you get your positive this side, by design it will just go through the diode and it will short out with the negative of the charger. So you can see now your positive is now here and your negative is now here. So if it goes in like this, instead of going all the way through and burning stuff in the circuit, it will just immediately as you plug it in, it will go in reverse, it will go through this diode and it will short out. So your charger is the one that shorts out. It's cheaper to replace a charger than to replace an entire laptop. That's the whole idea behind this. So most of the time, actually, those chargers, they've got protection circuits in them in such a way that if you plug and there's a short circuit, it cuts power. So if you remember, you've got chargers that will switch off the power light. So the charger will be on. It's LED to indicate that it's powered on, but when you plug it to the laptop, it switches off. So that's a mechanism which is designed in the chargers, especially if it's an original charger, that it will cut off if there's a short circuit on the output. So yeah, that's pretty much the application of a diode. So all you have to know about a diode is that it allows power to flow only in one direction. So now, depending on application in a circuit, a diode can cause a short circuit, a diode can cause an open circuit. So those two are not the same. So if this diode fails, you get a short circuit. I think I forgot an error somewhere there. No, my error is supposed to be here. Anyways, you get a short circuit if this diode fails. But if it's connected in this way, you've got your positive, your negative, goes like this. And you still have your positive going wherever it's going, and you've got your negative. If it's connected like this and this diode fails, you get an open line. Open line or open circuit. So that's why when you've got your multimeter powered on like this, it will be saying OL, open line, because it's not reading anything, it's not detecting anything. But when I do this, it's now saying there's zero resistance, but when I do this, it's saying open line. So if this diode fails, there is no reading between negative and positive, so you just get an open line, in simpler terms. That's another application of a diode. So if it fails in this case, you get a short circuit. If it fails in this case, you get an open line. It just depends on application. I think on MacBooks, yes, on MacBooks, the 2015 MacBook Air. Do I have a motherboard? I don't think I've got a motherboard. Not only the 2015 MacBook Air, even the 2012 MacBook Pro, pretty much all MacBooks, they've got a diode. So you would get your for the backlight circuit, power from the backlight circuit would come in through a diode, and then it will go to the LCD connector. So if that diode fails, you don't get backlight on the MacBook. So that's one application where if it fails, you get an open line. What else? What other application do you get? So the other application that you get with these is if you're working on power supplies. If you're working on power supplies, especially for, what are they called? For PlayStation power supplies, amplifier power supplies, TV power supplies, they apply diodes in making them into a bridge rectifier. I don't remember well, man. It's been a while. I think a bridge rectifier should be something like this. Correct me if I'm wrong, but I think it has to be something like this. something like that, and then you get another one here. Then I don't remember, you get your connection over here. I think it's your AC, and then you get your connection over here, DC. So one will be now positive and the other one will be negative. So yeah, you can correct me if I'm wrong, but it will be something like this. You get 4 diodes. So if one of them fails, your bridge rectifier doesn't work. So they're the ones that then convert your voltage from AC to DC. So one application will be this. This is a PlayStation 4 Slim power supply, and that's a bridge rectifier. So inside this, you've got this circuit, 4 diodes inside this thing. That's a bridge rectifier. That's its application. Let me see where else they apply the diode. These diodes over here, these are connected along a circuit. So if they fail, they would cause an open line. They are not connected across a circuit. Where else can I see one that's connected across a circuit? So one that's connected across a circuit, you just typically know by having ground on one side and positive on the other side. It's connected across the circuit. But if it's only connected along positive, you've got it connected in series. So yeah, if it's connected parallel to the circuit, it will be having ground on one side and it can cause a short circuit. If it's connected in series along the positive line, it will cause an open line. So yeah, that's pretty much it with diodes, guys. How do they look? That's one example of a diode on a laptop. Generally, it will look like this. Another type of a diode, you could get one that looks something like this. Come on, focus now. That would look something like this. So this one actually says PQ for the that's a MOSFET, but it will be having exactly a shape like this. Let me get a motherboard that I know has got that diode. Not so sure about this one, but yeah, I'm pretty sure it's there. Yeah. So we've got PD100 over here. So how does this happen? How does that work? So basically you've got 2 diodes inside. You've got your one diode over there, and you've got your other diode over there. So over here they combine and have one output. So this is out, this is in, this is in. So the way it works is that with this double diode, you could have power coming. It's an OR gate. Either 1 or 2 is achieved for you to get an output. It's an OR gate. So yeah, basically it will be using 2 diodes. You've got power coming in here and then it goes out. You've got power coming in here and then it goes out. So if one of them is on, you still get an output. Even if both of them are on, you get an output. That's how it applies here. So basically what you do is, what you have here is that you've got power coming in from your charging port. This is the DC inject. If I measure it, it's going straight to there. I know that for a fact. I'm gonna go into beep mode. So if I measure like this is ground, so that should be positive. Our positive is right over there. If you measure from that positive and we come measure somewhere here, there you heard the beep, there it is. So if you've got a connection coming from the charging port, so the moment you plug a charger here by the DC inject, that 19 volts goes straight into this diode here, it gives us an output through that resistor into the PQIC, which is the one that then sends a signal to these first 2 MOSFETs, a 24 volts signal to enable these 2 MOSFETs so that they can allow now power to get into the main power rail. So if you've got a faulty PQIC, you don't get a main power rail because it's not sending signal to these 2. At the same time, if you don't get 19 volts feeding this PQIC to activate it, that's the first activating signal. before you get any other activation signals, this 19 volts which goes through to switch on the PQIC is the first activation signal which starts everything up. So it will come through that diode, activate this PQIC. Once this is active, it sends a 24 volt signal to these two MOSFETs so that they can be enabled. Then that 19 volts from the charging port can go through these MOSFETs into the main resistor, into the main power rail, going into 5 volts, 3 volts over there, 1.8 volts, whatever, depending on the design of a motherboard. So that's one input. The second input, if I'm not mistaken, will be coming from directly from the battery. There we go. So directly from the battery. So the PQIC can either be enabled by a charger, that's why a laptop can switch on from a charger alone, or it can be enabled from a battery, that's why it can switch on from a battery alone, or it can be enabled from both of them at the same time. That's why your laptop can charge and use the battery at the same time. Simple. That's basically it. So that's another shape in which you can get diodes. So the first shape was the one that I showed. This is the second shape of a diode. The third shape of a diode on a laptop motherboard would be this one. This one. This is a diode. So that's a singular diode over there. It's pretty much the same as this one that I showed at first, but just smaller. So those are the shapes that you'd be looking for if you're looking for a diode. So remember, your ground can come from a diode if it's connected across a circuit, therefore it can cause a short circuit. And yeah, that's one point of failure. Second point of failure, if it's connected in series across, for example in this scenario, it's connected not across but in series along a circuit like this, it can cause an open line. So if this diode fails, this does not activate, you don't get any signal. Simple as that. Those are diodes for you guys, and I can see the video has been 17 minutes, so I'm gonna stop it now. Do MOSFETs on a separate video. I hope you guys learned something, and I hope you found this educational, and I will see you in the next video. Cheers and goodbye.